everybody. Welcome to the Learning to Go podcast. I'm your guest, Margie Meacham, the Chief Freedom Officer of Learning to Go and the author of the book Brain Matters, How to Help Anyone Learn Anything Using Neuroscience. My guest today is Travis Waugh. He's an instructional technologist at Georgia Tech, and he's the author of the TD at Work book, Behavior-Based Compliance Training. The reason I've asked him here today is to talk about learning technology. So, Travis, welcome. Let's start with telling our audience just what does an instructional technologist do?
That's a good question. I think in theory the idea is that I can be more strategic. So I've worked in e-learning for the last 10 years, really, developing e-learning tutorials and managing learning management systems. And the title, maybe traditionally was something like e-learning developer or e-learning designer. Our team at Georgia Tech is really trying to be forward-looking and thinking about how technology can really dramatically change the way we look at faculty and staff development. Instead of just making our tutorials a little bit more interactive or a little bit more engaging or building more content, how can we think about adult learning in a whole new way based on some of the Web 2.0, some of the really cutting edge technologies that are coming out. So they created the position about 3 years ago called Instructional Technologist. And the idea was there'd be a little bit more time carved out for research and to be more strategic and think about not just what are we going to do today with our instructional technology, but what are we planning to do 5 or 10 years down the line.
Well, then let's follow up on that. And in fact, that's exactly what I was so curious about is from your in your role, you're in a unique position you're actually being asked to forecast what's coming down the pike, what sort of disruptive technologies might really change the way we help people learn. So what are the big trends that you see coming down the pike for us?
Well, it's a great question. I think that I've always got one foot in the present a little bit and one foot in the future. I really enjoy futurist writers. I enjoy thinking about technology and watching which ones are going to catch on and not. I have a little bit of a model that I've worked on for trying to predict which technologies are going to catch on. Affordable, applicable, approachable is the 3-part rubric I use. You can look at a new technology and if you can see that it's cheap and that it solves a real problem. In other words, it's applicable and it's affordable. And if it meets people generally where they are, you're not asking them to put some weird layer of technology between them and their everyday experience or something that feels too foreign or too difficult. If it's approachable enough, then there's a pretty good chance it's going to catch on and really, really change people's lives. And I think there's a few technologies right now that maybe meet that criteria. And the one that I'm the most excited about by far is machine learning, and specifically what it allows in 2 big areas. And the one is predictive analytics. So we're getting a much bigger pool of data than we've ever had before, because pretty much everything we do is mediated through a technology of some kind, which means we're creating a data point with everything that we do. Obviously Fitbits are a very obvious example. Something that was very mysterious 5 years ago is now readily available to us and our health providers. Exactly what our heart rate is at any given minute, exactly how many steps we're tracking in any given day. But everything else, what time we turn our alarm off in the morning, how fast we drive to work, how often we stop at red lights or ignore them. There's a lot of auto insurance companies that are measuring those things now in your car. And all these disparate pieces of data could have been almost too much, right? If we human beings had to sift through it on our own to try to work out what was useful in that. And kind of the old model of scientific research was you had to have a theory first before you could test the theory. So I had to sort of think, well, maybe there's a correlation between people who drive too fast to work and people who commit HR infractions when they get there. I would have had to think of that, and then I would have had to go mine all the data, and the odds of all that coming together are very slim because there's all these other theories that are going to occur to me much more readily. The interesting thing about machine learning is now we've got all this big data, we can totally flip the paradigm of how we draw interesting conclusions from that data. We don't have to know what we're looking for anymore because the computer can just be constantly monitoring and surfacing correlations. So, you could imagine a world in the not too distant future where your HR performance software is tied to every single system in the organization, possibly even data points outside the organization. and you're just constantly getting red flags or red lights, things that you never would have guessed could possibly be connected, but it's drawing your attention to performance issues before they become performance issues. It's sort of predicting what's going to come next. There's already examples of that. The Atlanta Fire Department uses an algorithm to predict where fires are more likely to happen, and they do preventative spot checks of buildings that meet the criteria, and they don't even know what the criteria are. All the thinking is happening inside the machine, and it's based on so many different factors that you don't really have to understand why it works. You just have to look and say, oh, since we started following the machine's advice and doing spot checks, overall fires in Atlanta decreased by, I believe it was 30%. So it clearly works.
Okay, and of course, connected to that is machine learning, and the massive amount of data would not be possible without the Internet of Things, right? With all of those
Mm-hmm.
devices you're talking about being connected via the internet to send us the data. So those two those two technologies, my eye, go hand in hand, and I share my I'm interested in that too, and you find I talk about it in my blog quite a bit. So that's the first one, and I think learning professionals, we may be very aware of it in consumer environments, and even, you mentioned it's already happening like in fire departments. The NFL, certain teams in the NFL are using that wearable technology to enhance training techniques and to red flag potential injuries before they happen, to recognize that there might be added stress on a particular part of the body or something that's not quite performing the way they want. And that's an indication that they need to take a look at that athlete. So it's not long before it's going to be. I think it's the affordable thing. Um,
Mm-hmm.
but as learning professionals, how do you see that being applicable in the workplace? What do you think are some of the ways we might find ourselves using it?
That's a great question. Yeah, I think there's some short-term things that I'm playing with right now, actually. So the machine learning, the predictive piece is just one piece of it. Your analogy is perfect. It goes hand in hand. It's kind of a virtuous cycle. On the one hand, the machine learning is allowing us to make more predictions from data, but it's also allowing us to mine new kinds of data. So things like sentiment analysis, and you could be monitoring all the phone calls in the call center. You can strip people's individual identities out of it, because I know there's sort of a big brother concern that happens. But if the wrong kinds of words are showing up too often, the machines are smart enough now to gauge the sentiment, and you can give you a percentage and say, oh, the overall customer service health of this call center has dipped below 70%. It's time to deliver, more customer service training. And you think about the Internet of Things and single pixel browsers, and just like you could have, there was I can't remember the name of the company, but a big company that really bought into this idea. It's very similar sentiment analysis to what I described, although they were also just doing traditional surveys. But they had a giant a monument in the front of the building, so everybody saw it when they came in, and it was a visual color indicator of how happy the customers were. So if surveys were really high, it showed in a big green, and if surveys were getting low, it changed shades to red. And that was it was the internet browser that was only designed to show you one color for one metric. And that kind of thing just gets easier and easier to imagine, how you could maybe have a warning light above every cubicle in your call center, and as the machine is gauging sentiment and saying, uh-oh, this customer is suddenly very angry, the red light comes on, the manager knows to come over and provide some support. So that's
Wow.
kind of it's kind of cool, right? But to answer you, I mean, that's maybe a little bit more long term, just because there's so many pieces that have to come together. I mean, right now you'd still need a pretty talented programmer to be able to write all the API calls and mine all the right data and make it all happen in real time. But I'm excited about the idea of some rapid authoring tools that are allowing us to, start building some of these connections ourselves. And also what it allows us to do in terms of humanizing our learning. So one thing I'm working on right now that is very much allowed because of machine learning, possible because of machine learning, I should say, is a chatbot. So, lots of people are making chatbots, but it's gotten to the point where it's easy enough for somebody like me to do it. I'm not a formal coder, I should say. So, IBM Watson, you can use they have a cognitive service is what they call it, and you can get in and you can start saying, well, when a user expresses an intention like this, I want you to respond like this. And you think about how powerful that is, that you can program it with up to 25 intentions per instant. So if I was going to maybe create a purchasing training on campus. Maybe I don't have to create an hour-long tutorial anymore that tries to cover everything. Maybe instead I can identify the 25 problems that people are most likely to have with purchasing, create a chatbot that's custom tailored to them. It's on their cell phones, it's in their pocket. It becomes like a one-on-one coach. And that's the kind of thing that could completely shift the paradigm of what we consider organizational development and adult learning.
Yeah, and I've actually been on the receiving end of some of these chatbots as a consumer, and just to go in and test, and they are eerily. If right now, I think everyone still has to kind of get used to the idea. The first few times that it responds to you so appropriately, it's
Hmm.
startling. It's like, oh my goodness,
Hmm.
is that really just, bits and bytes and programming making that happen? But as we get more and more used to it, think about new leaders or salespeople in the field getting coaching on what their next step should be, and they're thinking about um, what do I lead with? What does this customer really want? So it could be very powerful, I think. And isn't it interesting, Travis, that you talked about humanizing the learning and customizing it and getting it to be so much more of this immediate, um, deeply personal, intimate experience, and that we're doing that with something we call machine learning. That these machines, this programming, unlike the old science fiction model where it takes the humanity out of everything, we're enhancing it with this technology. And I think that's the positive side of what's happening, the exciting, hopeful side of it.
Absolutely, yeah. I think it's fascinating. There's been some people who've written about this, how it makes us more human in a way. It seems so threatening at first, but Wired magazine, I think it was about 6 months ago now, they did an edition called The End of Code that was all about machine learning, and it was
Hmm.
really an interesting read. But there's some examples. A machine was able to beat a human in Go. So the Asian
Yes.
game that's kind of like chess, but much more complicated than chess. And back when computers started to beat humans in chess, they said, well, they're never going to beat them in Go. It's way too, it's basically Go is as infinite as the universe, and it's more about intuition and human understanding and reaction. Um, but eventually, it's true that you could have never programmed a computer to win Go in a traditional coding sort of a sense, where you're trying to think of every if-then statement that you could possibly need. But by unleashing machine learning and just uploading millions and millions of Go games, real games played between humans, into a database where a machine can start to build its own sense of how the game works and connections. It can start to practice, essentially, which is what machines are doing when we talk about machine learning. At first it's not very good. You ask it questions and sometimes it gets it wrong, but you can correct them and it learns, and that's where the magic happens. It says, okay, and that was wrong. I'm not sure I understand why it was wrong, but if I do that enough, then I start to get things right. And so it did win and Go, which is interesting. But I thought even more interesting was the Go player that it beat. It beat the world champion Go player, and he said it made him a much better player because there were
Yeah, the
moments where the
healer.
machine, exactly, the machine made a move that he never
Yes.
would have thought to make, and
Yeah.
it elevated them both.
Yeah. And I tracked that story as well. And in fact, I'll put a link
Hmm.
to this write up because I wrote about it in my blog at the time. And
Hmm.
another quote that came out of that is the winning move. The defeated champion said that the machine made a non-human move, made a move that would not have been thought of by a human being. But now it's in the literature of the game, and you know, uh, it opened up other theories. So I like to talk about the buzzword AI, artificial intelligence, is really, and there is another AI, it's augmented intelligence. And I think that's where the real promise is that as brain PC interfaces become easier and to use your three A's, affordable, applicable, approachable, and they become transparent, we're going to be having these communications with, if you want to call them machines, with these entities, these networks of machine learning that make us smarter, make make us more empathetic, bring us into another level of humanity. And I think that's a very exciting uh, time. That it's just like, we've used technology to enhance who we are in the past. You can go back to the automobile and what that did for human freedom and for the delimiting us, making us think that we could live anywhere, we could go anywhere, that we could do anything. And that, I think that's kind of baked into the American spirit because of our vast spaces and all of our highways. The idea of the automobile as an enabling technology. So I think that's where we're headed with the data analytics, that it's going to be very profound and it's going to hit us in ways that very soon are just going to feel like, well, this is just who we are.
Yeah, I read about that in your blog. I thought it was really interesting, the sort of direct brain influence and the brain computer interface. And yeah, definitely there's already, I mean, it seems like the one way aspect of the communication, there's a ton of evidence and research on there. Now, the machines are pretty good at reading our mind. They can use MRI scans to reproduce what we're looking at or tell how we feel about something. And that one-way part is key, because then you can design feedback loops that then start to change those things and maybe sense when our mood is shifting before we even realize it's shifting. And then, the brain is a powerful thing. Just maybe the right prompt at the right time can change quite a bit. And then I think your idea, taking it even further, of eventually where, it's actually the hardware is almost in our brains, in our memory. I mean, that's taking it even farther than I'd envisioned it at this point. I mean, you're definitely right. There's lots of people talking about that, but I think in the corporate learning space, it'll be interesting to see. Maybe I'm selling us short. I kind of feel like in the next 10 years, there's a lot of opportunity for the computers just outside of ourselves to change the way we work pretty dramatically. But maybe in the next 10 years, the way our brains work will be changed either by pharmaceuticals or machines.
Yeah, and or both. And one
Hmm.
reason why we talk about machine learning, but the reason all that learning is possible is that we started building neural we started mimicking what we learned about the brain. So it's this wonderful, to use your term again, a virtuous cycle, that the more we learn about the brain, the more we apply that to these artificial brains. And that's
Hmm.
why they learn better, is the trial and error learning, as opposed to, the if then way that we used to program computers. That now that we're building neural nets inside computers, digital networks that have almost an infinite way of connecting the dots, if you will, between data points, and work much more like our brains than they did in the past. We're finding far more possibilities and much more learning and pattern recognition, and much more usable output from these efforts than we had in the past. And so all those past predictions, like a computer will never be able to manage Go, well, that was before we could envision using a neural net model to do the programming.
Yeah, exactly. Yeah, and I really got excited when I saw Ashok Goodell, Professor Goodell at Georgia Tech speak. I think I read about, you must have saw this in your blog as well, but he was the Georgia Tech professor that had an instance of Watson that he programmed to act as a TA over the course of an entire semester of a master's level online course, and didn't tell the students in advance that one of the TAs was going to be a machine, and named her Jill. And nobody knew, nobody guessed in that first semester that it was not a human. Uh, in semesters since, he's kept doing it. He tells them up front now that one of the TAs is a machine, but he makes them guess at the end, and they don't guess very consistently. Real human beings are being accused of being a robot far too often. So, uh,
That's an exciting story, and I did write about it. And as a matter of fact, I'm surprised it hasn't gotten even more attention, because, as I understand it, he has passed the Turing test. So he has demonstrated a truly artificial intelligence that fooled enough of the people. I think it has to fool more than half the people into believing it's a human being, and he does it consistently. So, we already have artificial intelligence among us in a significant way. It's just a matter now of learning organizations figuring out, what do I do with that? And a teaching assistant is a wonderful way to use this technology.
Absolutely, yeah. It's interesting in a way, and of course, I don't know. You watch science fiction movies, and you think about, well, you create these artificial intelligent agents, and how, to what extent are they human? How much are they alive? And at least the instance of Watson that Professor Goodell used and that I'm trying to use right now to build a effective chatbot, it's a completely different kind of thing than that, right? There's really no way to say. I mean, it could get philosophical really quickly, but it's not doing any sort of thinking. It doesn't have any sort of sense of self or intentionality. It's just a different way to program, where you're building an adaptive algorithm instead of a fixed algorithm, and you're building something that's constantly improving itself. Which, as you mentioned, there are some actual the hardware has changed. It's much more like a neural net. Who knows where this could lead? But right now, it's interesting that something that's actually pretty simple is just saying sort of when somebody says something like this, respond with something like this, and then if it gets it wrong, you correct it, and it adds to the right entity list so that it gets it right the next time around. Even that can sometimes feel really uncanny and almost magical. You sort of think, okay, I expect to get this response, but every now and then you think, how did it know to give me that? Like, that's a better response than I would have given it myself.
Yeah.
It builds some pretty impressive connections.
Yeah, absolutely. And it's going to be fun. Hey, you know what, Travis? I could talk to you all day about this. And obviously, you know a lot of what's going on. And I've really learned from you in our chat. And I look forward to continuing to learn from you as we stay in touch. But let's just go to a question I'm dying to ask you. And that is, what are you working on right now that's got you most excited?
Yeah, well, so I'm still doing the nuts and bolts work of e-learning. So we're redesigning some of our tutorials in our library that I think are going to have tremendous value for Georgia Tech faculty and staff by taking up less of their time and giving them more targeted solutions that will actually solve problems. But the thing that I'm most excited about is the Watson app that I mentioned. Building it, learning how it works, seeing how it could be applied to multiple different problems. Our first problem is just going to be a simple advertisement, basically, for our training classes that we offer for Georgia Tech faculty and staff. So I'm calling it "What Would You Like to Learn Today?" And the whole purpose of this chat entity that we created is just to get a gauge on what people want to learn. It asks probing questions to ask them where they think they could use the most development, and then recommend a course back at them. So I think that could actually, I'm excited to see how big of an impact it has on our registration numbers. It'd be nice to have some hard numbers to see what people are willing to do. But it's also just, I could see somebody interacting with it. And I think the trick is the affordable, applicable, approachable. I keep coming back to it'll be free for my faculty and staff to use. It's just an online URL. So the question is, can I make it applicable enough that it overrides the sort of weird approachability of, okay, I'm chatting with a fake entity, and I think you can make it a little bit more approachable by adding some humor and by keeping it very short and focused so that it's not likely to get confused. But ultimately, you have to deliver that value so they can say, okay, if I go and I spend 3 minutes chatting to this fake person, it's going to give me a good recommendation that's actually useful for me.
Yeah, that does sound exciting. As a matter of fact, I love when you feel like you have some results to share. I'd love to have you back to talk to our audience about how it went and what you learned from that process.
Sure, I'd be happy to.
Okay, well, thank you, Travis. And how does someone get in touch with you?
Yeah, well, email is usually the best. Travis.waugh, Waugh, at ohr.gatech.edu. It's gatech.edu. And my information, if you Google me, I've got a website out there, and feel free to call. But I think I check the work email most often, and I'd be happy to hear from you.
Okay, and I'm sure some of our readers will take you up on that. So you've been listening to the Learning to Go podcast, everybody. I'm Margie Meacham, your host, and you've been listening to Travis Waugh, instructional technologist and a bit of a futurist there at Georgia Tech. Tune in next time. We look forward to talking more about the science of learning. Thanks, Travis.